Once upon a time there were two unicorns who were best friends, and their names were Sinbad, who was a boy unicorn, and Cosette, who was a girl unicorn. Now, these were no ordinary unicorns, for they both held PhDs in higher mathematics from a prestigious unicornversity. One day, Sinbad and Cosette were doing research off the coast of Madagascar when their boat was attacked by Somalian pirate horses. Sinbad and Cosette had forgotten to set their polar radar to radian mode and were caught unawares. The pirates wasted no time in capturing the poor unicorns. When Sinbad and Cosette came to, they discovered that they were tied up and surrounded by barrels.
Sinbad, we need to get out of here. I've read news stories about unicorns getting captured by Somalian pirate horses.
I know, Cosette. If I can just get these ropes off of my hooves, I'll go see if there's a way out.
We can cut off each other's ropes with our horns and then go look for a way out together, because together everybody achieves more.
Sinbad and Cosette freed each other and began to look for a way out. They had to hurry, because the pirate horses were coming back in an hour to cut off their horns. If they lost their horns, they would surely perish.
I found a hole between the boards behind this barrel. Maybe we can squeeze through it.
We should try to find the area of the hole to see if we can fit through it. I know that we can fit through anything with an area greater than 40 square centimeters.
Because Sinbad and Cosette were unicorns, the shape of the hole did not matter. They only needed to know if they would fit through when they disassembled into their unicorn auras.
This looks like the graph of y equal negative x to the fifth times e to the x from negative 5 to negative 1. We should try to take the integral to find the area.
This looks like we could use integration by parts to solve it. Let's each solve it separately to make sure that we get the right answer.
Sinbad and Cosette got to work solving the problem. Because they were both very smart and knew how to solve integrals without calculators, they finished quickly, although Cosette finished a bit quicker than Sinbad.
I got 46.013 centimeters squared.
Me too.
We can fit through!
Sinbad and Cosette squeezed through the hole and raced through the ship, but they were spotted by the pirate captain.
Don't just stand there, you fools! Get them!
Luckily, Sinbad and Cosette made it to the side of the ship, where they jumped overboard and swam frantically to their boat. They drove away quickly and reached free waters. They were terrified that the pirates would catch up to them.
Arg!
Once they felt that they were safe, Sinbad and Cosette relaxed. But Sinbad had a question for Cosette.
How did you finish the problem before I did? Our minds work at the same pace.
Oh, I just used the tabular method. Didn't you?
No, I used the basic ultraviolet voodoo method. Here's what I did.
First, Sinbad wrote out the formula and used limit to decide which factor was u and which was dv. Since polynomials are higher on the list than exponentials, he made x to the fifth equal to u and negative e to the x equal to dv. Next, he differentiated u and integrated du and plugged in the appropriate values into the equation. The integral of u dv equals uv minus the integral of v du, or ultraviolet voodoo. Because this equation had another integral to solve with integration by parts, he went through the process again. And again. And again. And again. And again. The last integral he could solve, though, so he knew he was at the end. Lastly, he plugged all the values that he found into the final equation and solved it to get 46.013 centimeters squared.
Oh, well here's what I did. It's called the tabular method. I must have learned it the year that we were in different calculus classes.
First, Cosette wrote down the integral that she was trying to solve. Here it is. Next, she drew a table with two columns, labeled differentiate and integrate. She used the same Lipit rules as Sinbad to decide which part of the original equation to put in which column. She put x to the fifth in the differential column as the u value, and negative e to the x in the integrant column as dv. Then she differentiated and integrated the columns until the value in one column was 0. This has to happen for this method to work, so it works best when one factor of the original equation is a polynomial. This is what she got. Next, she multiplied each value of the left column with the value below it in the right column, and multiplied the second, fourth, and sixth products by -1. Lastly, she added all of these values and solved the resulting equation from -5 to -1. She got 46.013 square centimeters, which is what Sinbad got too.
Well, I'm just glad that we're okay.
It would seem that math saved the day once again.